Sohcahtoa. In this video we're going to do a brief review of Sohcahtoa that we did in the last video, just because it is that important that you remember Sohcahtoa. Alright, so here we have our angle, and we're going to call it alpha. Alright, so let's make this a 3, 4, 5 triangle. So 3, 4, 5. And this is a right angle. It's not necessarily a 30, 60, 90 or any kind of special triangle, but it is a 3, 4, 5, and it is a right triangle. All right, now, if you remember, the side on the complete other side of your triangle from your angle is always your opposite side. Okay, and the side right next to your angle is always your adjacent side. Okay, always your adjacent side. It's adjacent to your angle. It's right next to your angle. And of course, the side opposite your 90-degree angle is your hypotenuse. Okay, so there's the three sides of our triangle. Now, if I asked you for the sine of alpha, well, sine is opposite over hypotenuse, so you would give me 3 over 5. All right. If I asked you for the cosine of alpha, cosine is adjacent over hypotenuse, so you would give me 4 over 5. And you would not reduce these fractions. Just leave them alone. Don't convert them to decimals. If they were reduced, like say 3 over 6, you go ahead and reduce that to 1/2. But otherwise, leave them alone. Don't convert them to decimals. And if you notice, it's the sine of the angle is 3/5. It's not the sine of 3/5 equals something. It's the sine of whatever angle it is 3/5. In later videos, I'm going to show you how to get the angle. But for right now, we're just going to call the angle alpha. All right, and then your tangent is opposite over adjacent, which means that is 3/4. Okay. Now your reciprocal trig, your cosecant. All right, remember your cosecant is the inverse of sine, which means it's 1 over opposite over adjacent, or hypotenuse over opposite, which is 5/3. Okay. Your secant of alpha is the reciprocal of cosine, so it's hypotenuse over adjacent, or 5/4. And then of course your cotangent of alpha is the reciprocal of tangent, so that's adjacent over opposite, which is 4/3. And again, just leave the fractions alone. Don't try to convert them to decimals. If they're improper fractions like all of these are, don't change them either. Just leave them as a fraction. Nothing wrong with a fraction. Just leave the fraction alone. Okay? Now, here is 2 of our special triangles. What I want you to do for a you try, real quick, shouldn't take you very long, is fill in, okay? Fill in the blanks. Take a few seconds, fill in the blanks. Go. All right, so this one you should have said S, or for this case, let's make it 1, which would make this 1, or S, which would make this S times the square root of 2, or just the square root of 2. All right, because I'm substituting in 1 for the S, so this would be 1 square root of 2. Same thing over here. All right, opposite to 30 is your smallest angle, so your smallest side, so 1 square root of 3 and 2, because your ratio is S times the square root of 3 and 2S. All right. Now, the reason I want to go ahead and put in numbers there is because now we're going to get into what are the cosine, sine, and all of that of some specific angles. Okay. So, and we're going to use these triangles to figure it out. Well, all except for 90. All right, so 30 degrees. What's 30 degrees in radians? Well, multiply it by pi over 180 and reduce. You'll get pi over 6. 45 degrees, same thing. You'll get pi over 4. 60 multiply out, you'll get pi over 3. And 90 you should already know is pi over 2. Now, the sine of 60 degrees. Well, let's look up here. Here's 60. Sine is opposite over hypotenuse, so opposite is square root of 3. Hypotenuse is 2. Oops. You'll probably want to write this stuff down, guys. Okay. What's the cosine? Well, cosine is adjacent over hypotenuse, so it's 1/2. And the tangent is opposite over adjacent, which is the square root of 3. Now these are just the reverse, so it's going to be 2 over the square root of 3. And when you reduce that, that's going to equal 2 times the square root of 3 over 3. The secant is going to be just 2. And the cotangent is going to be the square 1 over the square root of 3. When you rationalize the denominator, it's going to give you the square root of 3 over 3. Let me write that a little more legible. All right, let's do 45. What's the sine of 45? Well, it's opposite over hypotenuse, so it's going to be 1 over the square root of 2. Rationalize the denominator, so it's the square root of 2 over 2. What's the cosine? It's going to end up to be the same thing, square root of 2 over 2. What's the tangent? Just 1. So it's opposite over adjacent. What's the cosecant? And that's just going to be square root of 2. Secant, also square root of 2. Cotangent, that's going to be 1 again. Now let's do 60. What's the sine of, you know what I did? Alright, I did 60 up here. So scratch this out. I make this 60 degrees. I looked at the wrong angle. Scratch this out and do 30 degrees. Alright, I reordered them from my chart that I'm looking at. I reordered them here. So just make these 2 corrections. Don't worry about changing all this. Just make these 2 corrections. Okay. This is now radians here. This will be your pi over 3. And this will be the pi over 6. Alright, so just make those couple corrections. That'll be the quickest way to correct than trying to correct all of these. Alright. So now let's look at 30. 30 degrees right here. Alright, so what's the sine? Well, it's opposite over hypotenuse, so it's 1/2. The cosine is adjacent over hypotenuse, so it's the square root of 3 over 2. The tangent is opposite over adjacent, which is 1 over the square root of 3, which after you rationalize is the square root of 3 over 3. The cosecant is the sine flipped upside down, so 2. The secant is the cosine flipped upside down, so 2 over the square root of 3. When you rationalize that, it's 2 times the square root of 3 over 3. Then the cotangent is the flip of the tangent, so 1 over square root of 3 just becomes the square root of 3. All right. Now, for 90. 90 degrees, you can't use the triangle. But if you remember from a few videos ago, back when we went over the unit circle briefly, I gave you some special some special sine and cosine values. So hopefully you wrote those down, flip back in your notes, and you'll see that the sine of 90 is 0. The cosine of 90 is 1. Now remember, the tangent is sine over cosine. So the tangent of 90, okay, I got those backwards. The sine is 1, sorry. It's late. So it's the tangent is sine over cosine, so this does not exist. Because you can't divide by 0, it would be 1 over 0, which does not exist. The cosecant is the flip of the sine, which is 1 over 1, which is still 1. The secant is the flip of cosine, which would be 1 over 0, so that does not exist. And then the cotangent is the flip of the tangent. Well, the reciprocal of does not exist is 0. All right. So this chart here, I would write this down and remember it. This is kind of a shortcut chart. When we get to our unit circle, this will make a little more sense. Okay. And this will also be helpful with the unit circle. All right. But if you remember these values, okay, if you remember these values, when we're doing sine and cosine of triangles, okay, especially if they have one as a side length, you'll be able to rattle them off real quick, no problem. Okay. Plus, this is also help in remembering Sohcahtoa. All right, this will probably show up on your test at the end of the unit, so make sure you know how to do this. Okay. It's just simply sine and cosine of those triangles. And remember, I also gave you 90 a few videos ago. That was back in the unit circle and basic trig video, which you should still have your notes from. All right. Important thing is make sure you know how to do Sohcahtoa. All right. Sohcahtoa is extremely, extremely, extremely important in pre-cal, even more so than in geometry. All right. So make sure you understand Sohcahtoa, and you can give me and you can fill this table out pretty much on command. All right, because it will show up on your test. All right, that has been your Sohcahtoa video. I will see you tomorrow in class. Be ready to tackle some more problems on Sohcahtoa. See you tomorrow.